Hello there and welcome to Lower 6th Further Maths Pure Core Past 1, June 2013. Here we're working on question 4 from FP1, it was question 8. So first of all we're looking at the matrix A above here and we need to prove that A squared equals 7A plus 2I. Now what I is referring to here is the identity matrix of 1, 0, 0, 1, the 2 by 2. So A squared is the same as A times A. So 6 minus 2 minus 4, 1 times 6 minus 2 minus 4, 1. So let's times these matrices together. Remember, you can check this on your calculator at the end, but I'm going to just quickly do it here. 6 times 6 is 36. Take away, or actually add 8. So 36 add 8 is 44. The next one, working across the column, across the row and down the second column this time. It's going to be 6 times minus 2 is minus 12. Take away another 2 is minus 14. Minus 4 times 6 is minus 24. Take away another 4 is minus 28. And minus 4 times 2 minus 2 is 8. Add another 1 is 9. So that's the left hand side. Now what I need to do is check that that will equal the right hand side. So what I mean by 7 times this matrix A is that 7 is going to multiply by all of the cells inside this matrix. And then we're going to add that on to 2 times the cells inside the second matrix, 1, 0, 0, 1. So 7 times 6 is 42, add 2 times 1 is 2, so that would be 44. 7 times minus 2 is minus 14, add 0, that's just minus 14. 7 times minus 4 is minus 28, add 0, so that would just be minus 28. And 7 times 1 is 7, add 2 times 1 is 2, so that will make, 7 times 1 is 7, so that will make a 9. Perfect, this matrix here equals this matrix here, just as we wanted. So part B then looks for us to show some identity or expression or equation here to do with matrices. Probably going to correspond from this equation at the top here. So A squared equals 7A plus 2I. So what I'm going to do is I'm going to look to rearrange using my rules of matrix algebra manipulation to get this value here. So I need to somehow create an A minus 1, it looks like, and then half it, so probably times by 2. So it's probably going to be this I here. I need to turn that into an inverse A. So what I'm going to do here is I'm going to multiply pre or post. I don't think it particularly matters. Let's post multiply by the inverse of A. So that means A squared A inverse equals 7A plus 2I times inverse A. I think if you did this at the front it wouldn't really matter too much either. I've just done it at the back. Right, now let's simplify this a little bit. A squared, that's just A times A. So A times inverse A. Two of those matrices there will cancel out to make an I. A times the I matrix will just give me an A matrix. On the right hand side, I can expand my brackets. You still can expand brackets when you're doing matrices, just make sure you've got them in the right order. So 7A times A inverse, add 2I times A inverse. Let's look to simplify this up a little bit. So A times A inverse, that will cancel out to an identity. Make sure you don't just leave 7 hanging there on its own. It needs to be a matrix still, so leave it with an I there. And then I times the inverse of A. Anything times the identity is itself, including the inverse of A. So I've got my A inverse now, looking back up at the formula I'm trying to get to. So all that's left for me to do now is just rearrange it to make this A minus 1 the subject. Take away 7i from both sides. A inverse, so A, take away 7i equals 2 lots of the inverse of A. And divide through by 2, so a half of A minus 7i will equal A inverse, just as required. Great, so I put my little square there. Okay, the next question is the transformation represented by the matrix A, the point P onto the point Q, given that Q is this coordinate, where K is a constant, find K in terms of P. Right, okay, so what's happened here is our matrix A has multiplied by the coordinate P to get to the coordinate Q, which is 2k plus 8 minus 2k minus 5. So our quest today is to find P1 and P2. So what we're going to have to do here to get rid of that matrix at the front A is we're going to need to pre-multiply by the inverse of A. So what this is going to look like is P1 and P2 is going to equal the inverse of A. Now first we need to work out what the inverse of A is. So I could either do this straight on my calculator, or I think what the question is looking for me to do is use this expression here. So the inverse of A is going to equal a half of my matrix A, 6 minus 2 minus 4, 1, take away 7, 0, 0, 7, which isn't too bad, that's not such a long calculation. 6, 7 is minus 1, minus 2 take away 0 is minus 2, minus 4 take away 0 is minus 4, and 1 take away 7 is minus 6. So my inverse A matrix is a half, minus 1, minus 2, minus 4, minus 6, times by my Q matrix, 2k plus 8, minus 2k minus 5. So, leaving the half at the front, let's expand the two matrices. We work along the row in the first matrix and down the column in the second matrix. So minus 1 times 2k plus 8, that's minus 2k minus 8. Add on minus 2 times minus 2k plus 5, so that would be plus 4k plus 10 from double negatives there. And for the second part, it's going to be minus 4 times 2k plus 8, so that's minus 8k minus 32, and minus 6 times minus 2k plus 5, minus 5, so that will be plus 12k plus 30. So in this case here, for the top row, I'm going to get 2k plus 2, and for the bottom row, I'm going to get 4k minus 2. So halving the coordinate here, I'm going to get k plus 1 and 2k minus 1. So that's the coordinate of P, 8 marks.